Now, the next statistic that we're going to talk about today is the histogram. So the histogram is a visual tool for summarizing responses. The histogram is something that you use when your data are of the interval or ratio level type. This picture that you'll get using this histogram will give you a sense of the proportions and the percentages of people that responded in different ways. A histogram, as you'll soon see, is very similar to a bar graph, except for when it comes to the histogram, there's going to be no space in between the bars. So here's an empirical distribution. It's based off of the Harrison County, Kansas juvenile court decision-making data. There were 634 cases that were part of this sample. In the first column, we can see the number of prior referrals that the youth involved in these cases had. And we can see that the number of referrals ranges from 0 all the way up to 6. So this is considered a ratio level measure in the sense that you can have 0 prior referrals, 1 prior referral, 2 prior referrals, and so forth. And the only reason why we stopped at 6 was because that was the maximum value we observed in our sample. So what we can do is we can represent this information using a histogram. So the values at the bottom along the x-axis, those represent all the values we observed in our sample of juvenile court cases. They represent the number of times the youth involved in the case have been referred to the justice system in the past. So we can see that there's 0, 1, 2, 3, 4, 5, and 6. Each bar represents the number of cases involving youth who had been involved in the court in the past, the number of times on the x-axis. So we can see that just under 300 cases involved youth who had been involved in the court in the past 0 times. The next bar shows the number of cases involving youth who had been involved in the court in the past 1 time. And we can see that there are approximately 150 youth who fall into this level. Since this is a ratio level measure, we want the bars to touch each other, indicating that all the values from 0 to 6 have been accounted for in this picture. And we can see that in total, all of the values that we observed make up this kind of wedge-shaped shaded area. So it's one shaded area. Now I want to point out that with the histogram we just looked at, along the y-axis we had the counts. But what we could also do is replace those with percentages. So we could look at the histogram to the right, and we can see the bar representing all the cases involving youth who had not been involved in the past. And we can see that this bar is somewhere between 37.5 and 50% of all of our cases. So it's roughly equal to 45%. The next bar shows roughly 25%. So we can look at these 2 bars and get the idea that maybe 65 to 75% of all of the cases involved youth who had been involved in the past between 0 or 1 time. Now when it comes to making these histograms, there's a concept known as bin widths. So So this idea of bin widths is really similar to the notion of intervals that we talked about when taking a ratio level variable and turning it into an ordinal level variable. So bin widths are what we do to take values of a ratio or interval level measure and group them together. So here, a bin width, this is a number of different values are represented by each bar. So in the histogram we just looked at, every bar represented one value. But what we could do is we can construct a new bar that represents all the values in, say, the first and the second bars. So we talk about bin widths because by adjusting the bin widths, we can reveal different features in the distribution of our data. So bin widthing is analogous to working with a microscope. So when we're working with a microscope, we take a slide, we put it under the microscope, and we have to adjust it to get a clear picture of what's going on the slide. So by adjusting bin widths, we do effectively the same thing. The big difference, though, is that when we adjust bin widths, it's not that there's one perfect way of viewing things. It's that as we adjust the knob, we get another new way of looking at our data. So there's no perfect bin width, only perfect bin widths. So here's an example from the Prison Climate Survey. This one's using the full sample of 601 inmates and staff. So these data represent the number of months individuals were involved with the prison system. The x-axis shows the number of months people were involved within the system, and the y-axis shows the number of people who were involved for those periods of time. With this first plot, the bin width is set to 1. So every bar represents a 1 month difference. Looking at this plot, we see lots of little bars. They're kind of hard to see, but we get a sense that the bars are largest the closer towards 0, and that the bars tend to get smaller as we get to those larger month values. Another way of representing the same information is to increase the bin width to, say, 10 months. So in this second histogram, the width of these bars represents a 10-month interval. Looking at it this way, we get a similar picture to what we saw in the first histogram. Again, we're seeing that most of the respondents of this survey had been involved with the prison system for a shorter interval of time, but that as we start moving out to the right, we see that there are fewer and fewer people who are involved with the system for a long period of time. Now, both of these are representing the same data set. The one on the right gives a really clear picture of that decline. So there are more people involved in the prison system for shorter periods of time than there are people who have been involved in the system longer periods of time. Now, if we look at the first histogram again, we get that same information, but we also get additional information. So if you squint, what you'll see is that there are actually 3 peaks that occur as you move from left to right. So closer toward that 0-month mark, there's a big spike. And then if you get closer to that 200-month mark, there's another big spike. And then as you get out to that 300-month mark, there's a third big spike. So again, it's the same data. We're using a histogram to look at it. And if we adjust the bin width, we can look at the same data, but in different ways. And each one of these histograms can give us additional information about what's going on in our samples. So another visualization technique that we can use is one referred to as a line graph or a polygon. So the line graph or the polygon is effectively the same thing as a histogram, except for instead of representing the data by bars, what we do is we represent the data using lines. So here are the same prison climate survey plots that we just looked at. But instead of representing these number of months by bars, what we've done is we've identified the maximum number of people for each of these intervals, and we connected those together using lines. So if we look at these two line graphs, we get similar information that we got from our histograms. If you look at the one to the left, it's a lot noisier, it's harder to read, but we also get the sense that there are maybe 3 distinct groups of people who've been involved in the prison system. So there are people who've been involved in it for a short period of time, those who've been involved in it for, again, under 200 months, and then those who've been involved for around 300 months. We also get the vague sense that most of the people who are in prison have only been there for a short period of time, and that those who've been in prison for a longer period of time are a lot more rare. In the same way that we were working with histograms, we can increase the bin width. So here I've increased it from 1 to 10. So from 1 month to 10 months. Doing this, we get a clearer image of that decreasing trend. So most of the people who are involved in prison are involved for a shorter period of months, and then it becomes increasingly rare to find people who've been involved in the prison system for large numbers of months. And by increasing this bin width, we get a much clearer representation of that trend.